'Twas the night before Christmas, and all through the stars not a creature was stirring, at least not on Mars. But deep in the void where dark matter flows, the next great discovery quietly grows. Winter is one of the best periods for stargazing. The longer, clearer nights offer some of the best celestial sights. As we look up at the sky this time of year, we remind the universe is itself a grand and ancient gift, one still wrapped in mystery. Maybe discovery, like Christmas, doesn't come from a store. Maybe discovery, perhaps, means a little bit more. Every time we unwrap one of the cosmos' secrets, it feels like opening a present, one that deepens our wonder but also our responsibility. Because knowledge, like any true gift, comes with care, for the worlds we explore, the minds we expand, and the civilizations that might one day share that same awe. And we have still got a lot of presents left to open. There are entire galaxies of mysteries still hidden in the night sky, vast cosmic voids stretching hundreds of millions of light years across, where matter seems to vanish without explanation. The Great Attractor, quietly tugging whole galaxies across intergalactic space, its source still unseen. The Three-Eye Atlas object, an interstellar visitor whose origins defy easy explanation and which exhibits strange behaviors. Tabby's star, whose flickering light once made us wonder if alien megastructures might be casting shadows on its face. The cold spot in the cosmic microwave background, a patch of sky so strange that even inflation theory hesitates to explain it. Rogue planets drifting alone between the stars, countless dark wanderers, maybe outnumbering all the suns combined, and the quiet puzzles closer to home, dark matter, dark energy, neutrinos, and the ever-elusive question of what, exactly, reality is made of. We tend to think of discovery as something humanity does to the universe, a conquest of curiosity, but sometimes it feels the other way around. The universe seems to want to be discovered. It leaves clues, hints, cosmic breadcrumbs scattered across space and time, inviting us to unwrap one mystery after another. Normally, we pick a topic and deep dive it, but this Christmas we'll see just how broad the ocean to sail still is, as we take a moment to appreciate those unopened gifts, the hidden worlds, the cosmic anomalies, and the great unknowns that still wait for us to notice them. Because the best presents are not the ones we already understand, but the ones that change us when we open them. So grab a warm drink and settle in, because today we'll be exploring the universe's unopened gifts, and how the spirit of discovery keeps us reaching for the stars. The Hidden Universe, Seeing the Unseen. If the universe is a gift, then most of it is still wrapped. We spent centuries unboxing the cosmos, layer by layer, first discovering the planets, then the stars, the galaxies, and finally, the great unseen architecture holding it all together. But even now, after all our telescopes and theories, most of existence remains invisible. Astronomers call it dark matter and dark energy, but those are really just placeholders for our ignorance, labels for what we don't yet understand. Together they make up about 95% of the observable universe, everything we've ever seen, every nebula, every planet, every photon that's ever reached a human eye or telescope makes up the last 5% of everything. We live surrounded by invisible giants. Dark matter is the scaffolding on which galaxies form, the unseen threads that stitch together the cosmic web. We can't touch it, can't see it. We can watch its gravity bending light and steering stars. Dark energy is stranger still, a silent pressure stretching space itself, pulling galaxies apart faster than gravity can reel them in. The largest, most powerful force in the universe, and we don't even know what it is. Even the visible parts of the cosmos hide from us. Rogue planets drift lightless between the stars, perhaps trillions of them, unseen worlds with molten cores or buried oceans, or galaxies lurk behind dust clouds or the glare of quasars, neutrinos, ghost particles that pour through your body by the trillions every second, barely interact with normal matter at all. They are the quietest messengers in the universe, and yet they carry the story of stars and supernovas. They and dark matter alone offer us a chance to possibly look beyond the surface of last scattering, the wall in time and at the edge of reality that curtains off the first 400,000 years of the universe from our view. When the universe was smaller and hotter, akin to the surface of the sun, Photons of light emerged in the visible range and rarely traveled far before being absorbed once more by other matter. As the cosmos cooled, matter thinned and also shifted to a form that absorbed less, and even today many photons of light are left over from that time, though so redshifted we call them cosmic microwave background radiation. But matter that interacted only weakly with other matter, like neutrinos and dark matter, were not being absorbed and re-emitted in this era, and many will be left over from that time for us to see back even further, toward that moment when the cosmos was created from we know not what. Indeed, we have no idea if anything existed before our universe, or if anything lies beyond it. Even within what we can observe, we are confident the universe extends far past those borders. We often say the universe was born from an infinitesimal point, but that really only describes our observable portion, the cosmic bubble we can see. The universe is expanding, driven by the mysterious force we call dark energy. For every 140 million light-years you move apart, the rate of expansion between those two regions increases by 1% of light speed. By around 14 billion light-years of separation, that expansion reaches the speed of light itself, and anything beyond that recedes faster still, forever beyond the reach of new light from us, or ours from them. Yet we still see their ancient glow, fossil light from photons that left those regions billions of years ago, back when they were much closer. Those photons have been stretched across eons to reach us today, showing us relics from the universe's early youth, now as far as 46.5 billion light-years away. How much farther the cosmos extends we simply do not know, perhaps infinitely so, and that's without even considering stranger possibilities like alternate universes or entire multiverses beyond our cosmic horizon. It's easy to forget that the sky we see is just one narrow slice of reality. The human eye only perceives a tiny band of the electromagnetic spectrum, a little rainbow of colors between radio and gamma rays. When we first built telescopes to see into those other bands, it was like opening a dozen more windows into creation, each revealing a new universe layered atop the old one. Radio telescopes gave us pulsars and quasars. Infrared saw through the dust to newborn stars. X-rays showed us black holes feeding. Gamma rays revealed the death throes of the most massive stars of all. Every time we invent a new way of looking, the universe gives us another surprise. It's humbling to realize that our understanding depends so much on the senses we bring to it. Imagine if we had evolved eyes that could see neutrinos, or brains that could feel gravity the way we feel warmth. The cosmos might look very different to us. So often the key to discovery is learning how to see anew. And as our instruments improve, the James Webb Space Telescope, gravitational wave observatories, neutrino detectors buried in Antarctic ice, the invisible begins to shimmer into view. We're starting to map the true structure of the cosmos, filaments of dark matter stretching hundreds of millions of light years, like strands of spider silk spun between clusters of galaxies, or the neurons of some incomprehensibly vast mind. Where once we saw emptiness, we now see the subtle glow of cosmic structure. But even with all this progress, we're still children at the tree on Christmas morning, surrounded by boxes we can't yet open. We can shake them, listen to them, guess at what's inside. Sometimes we tear off a corner of the wrapping and catch a glimpse of something astonishing. A new particle, a gravitational wave, a rogue planet tumbling into the void. The more we discover, the more we realize how much remains unseen. And maybe that's the real miracle of the universe, that's not finished revealing itself. It still holds mysteries waiting for minds curious enough to seek them. Every hidden force, every dark world, every unseen energy is a reminder that the cosmos is bigger, stranger, and more generous than we can yet imagine. We are not running out of discoveries, we're running out of ways to describe them. Cosmic anomalies, the clues we can't ignore. The universe may be vast and ancient, but it still finds ways to surprise us. Every so often, nature throws us a curveball, something that doesn't fit neatly into the patterns we've come to expect, or maybe a bowling ball, as once discovered they tend to crash around inside the structure of accepted theories, knocking over key pins of prior understanding. These are the cosmos's riddles, and perhaps its mischievous gifts, wrapped in paradox and tied with the bow of uncertainty. Take Tabby's star, for instance. When astronomers first noticed its strange, uneven dimming, it looked almost as though something enormous, perhaps even artificial, was crossing its face. Alien megastructures, while an exciting option, were soon ruled out, but the real answer still eludes us. Dust, comets, or something stranger still? We do not yet know, but that moment of mystery rekindled a spark in all of us, the reminder that we don't have it all figured out yet. Then there's Oumuamua, the first confirmed interstellar visitor to our solar system. It didn't behave like an asteroid or a comet, and no one can quite agree on what it was. Perhaps a shard of a shattered world, or the husk of something built long ago and far away. Whatever it was, it whispered of other suns, other stories, and other travelers adrift in the interstellar dark. Now with 3i Atlas, we reconsider these options once more. A thing that's like a comet but no comet, and ask ourselves about its origin and nature. We see the same pattern across the cosmos. Fast radio bursts that flash for milliseconds from distant galaxies, galaxy rotation curves that refuse to match our models, cosmic voids stretching for hundreds of millions of light years, and the great unseen hand of dark matter and dark energy shaping all that is, and ever was, and ever will be. In all these cases, we've done episodes to look at them, and I discourage folks from seeing alien hands in these strange occurrences, as the case for them never seems to add up to a plausible one, thus far anyway. And yet even if totally natural, they offer astonishing and wondrous insights into an ever more fascinating cosmos. Each one of these anomalies is a message, not of failure in our science, but of invitation, a hint that the universe still has chapters left for us to read. Science, after all, grows not from what we understand, but from what we do not. Even the cold spot of Eridanus in the cosmic microwave background, that one quiet patch of sky where the afterglow of the Big Bang fades far more than it should, might be telling us something profound. A trick of statistics, or a window into another universe entirely. A sign of inflation the instant after the Big Bang. A non-entropic alien empire. The ghost shadow of an early universe. A fossil of conformal cyclic cosmology. We can only guess. But that's the magic of anomalies. They remind us that discovery is not about confirming what we already believe. It's about unwrapping the things we never expected to find. Hidden worlds in our own backyard. Not all the universe's unopened gifts lie among distant galaxies on the edge of space and time. Some are right next door, quietly waiting beneath ice, stone, and shadow. We used to think life could only thrive on worlds like ours, warm, sunlit, and alive with oceans and air. But the more we look, the more we find that the darkness hides its own kind of light. This year we have explored many of those. Beneath the frozen crust of Europa, oceans deeper than Earth's hide beneath a roof of ice. Enceladus, Saturn's tiny moon, jets plumes of water vapor into space. Salty, organic, alive with chemistry. Even Mars may still shelter liquid water deep underground, far from cold and radiation above. In the outer reaches of our own solar system, countless rogue planets may drift through space, entire worlds without suns, warmed only by their cores, or blanketed in thick hydrogen atmospheres that trap heat like a cosmic thermos. One day soon, these dark and frozen lands may come to life, waypoints in our journey to the cosmos, filled with industry and gardens and new branches of humanity. Even Earth keeps secrets, deep microbial ecosystems thriving below the ground, in lakes buried beneath miles of Antarctic ice or within volcanic rock. We've found life at crushing pressures, boiling heat, and in complete darkness, each one proof that we've barely scratched the surface of our own biosphere, itself but a thin shell around our tiny pale blue dot. And we still do not know the origin of that biosphere that seems to have arisen billions of years ago, and we've explored the options from oceanic thermal vents to tidal pools to phosphorus-laden lakes, radioactive geysers, and even off-world cometary bombardment. As we spend a few more months blanketed in darkness and snow, I hope you'll take some time to enjoy all those episodes if you've not seen them yet, and we have many more to come. So don't forget to hit like and subscribe, and hit that notifications button. Needless to say, it's humbling to realize how much the universe's mystery begins just beyond our assumptions. Every age of discovery has found its new worlds, not in distant stars, but in the unexamined corners of its own backyard. Many mysteries remain on Earth, only now we can also find more of them in the wider solar system and the grand cosmos beyond. As 2026 looms, we find no shortage to the puzzles left to unlock. Today we've been talking about hidden worlds and unopened gifts the universe might be holding back from us. Over on Nebula, my new exclusive, Rogue AI Empires, When Machines Expand Without Us, looks at a different kind of surprise. What happens if our machines keep going long after we are gone? Nebula is our creator-owned streaming home for thoughtful, imaginative videos, where every episode of SFIA appears early and ad-free, plus monthly exclusives like Rogue AI, dozens of bonus and extended editions, and brilliant work from other channels like Curious Archives' Sympathy for the Machine, which explores themes of machine minds that have gone rogue, but maybe for good reasons. Right now, there's a special deal. If you use my link or the QR code, you get 50% off a yearly subscription. It's now just $30 for the whole year, about $2.50 a month, and new viewers get a 3-day free trial. Visit go.nebula.tv/IsaacArthur to join us there, and check out Rogue AI for free. Beneath the Quantum Veil. And for all the grand wonders in the wider cosmos, or beneath our very feet here on Earth, there's a hidden layer of reality beneath the mundane matter that makes us up. The quantum realm, and below that the Planck scale and possibly strings. For all our progress, physics still stands before a locked door, one labeled unification. Einstein's smooth, elegant spacetime won't quite mesh with the jittering chaos of the quantum world. Somewhere between the vast and the tiny, the equations break, and we are left staring at the seam. Relativity describes the grand stage on which the universe unfolds, a continuous fabric of space and time warped by energy and mass. It explains how planets orbit, how light bends, and how time itself slows near a black hole. But zoom in far enough to atoms, quarks, and the fluctuations of empty space, and that smooth fabric dissolves into a storm of uncertainty. Quantum mechanics paints a very different picture. A world built not on continuous curves but of probabilities, where particles flicker between states and even empty space seized with virtual energy. Our universe seems to exist like the rippling surface with a vast sea beneath, and it may be that we could poke a hole in that surface and flood all reality, our false vacuum, with a new one, something we explored recently. Quantum field theory, the most successful physical framework we've ever built, unites 3 of the 4 known forces, electromagnetism and the strong and weak nuclear forces, into a precise mathematical model. It predicts particle masses, lifetimes, and behaviors so accurately that we can measure them to a dozen decimal places. And yet, gravity stubbornly refuses to fit, and for my part, I'm not sure that it needs to. General relativity is a geometric theory, describing gravity not as a force but as the shape of space-time itself, while quantum theory describes everything else as fields vibrating within that space-time. Trying to quantize gravity has been like trying to draw straight lines on a surface that keeps shifting under the pen. A true theory of everything would weave together these incompatible pictures, explain how the smooth curvature of space-time emerges from, or interacts with, the jittering quantum vacuum. It would reveal whether gravity is an emergent effect, a quantum field of its own, or something even more fundamental that gives rise to both geometry and matter alike. The Standard Model has taken us far, predicting new particles like the Higgs boson decades before we saw them, but still only describes about 5% of what's out there. The rest, dark matter, dark energy, and perhaps entire hidden dark sectors of particles that barely touch ours, lies outside its reach. Some suspect the missing physics hides in supersymmetry or string theory. I remain a skeptic, though they are strong arguments. Others think we'll find it in new forces, new dimensions, or a deeper understanding of quantum spacetime itself. Each generation builds a bigger collider, a sharper telescope, or a more precise detector to probe that frontier, but the most profound breakthroughs may not come from brute force, but from new ways of thinking about reality itself. Somewhere beneath that quantum veil, the universe is whispering the next line of its story. What we call particles may be patterns of information, fields vibrating through an unseen medium. The next breakthroughs might come not from bigger colliders but from quantum computers and gravitational wave observatories, letting us glimpse the quantum foam at the base of being. The smaller scales may yet hold the biggest surprises. perhaps the seeds of new universes, or the codes that write this one. The Living Frontier. If the subatomic world is the foundation of reality, then perhaps life is its experiment in self-awareness, the cosmos learning to look back at itself. We still don't know how life began, only that it seems determined to survive in every niche we can imagine. And again, we explored that much this year and will more next too. From hydrothermal vents to acidic lakes, from Europa's hidden oceans to Titan's methane seas, the boundary of habitable keeps expanding. Each new discovery raised the same thrilling question. If life arose so quickly here, how could it not do so elsewhere? And beyond biology lies the enigma of consciousness, how matter begins to think, to feel, to dream. It's one of the new frontiers where physics, philosophy, and neuroscience all blur together. We can trace neural pathways and measure brainwaves, but the subjective spark, the awareness itself, remains outside the lab. Our own creations are joining that mystery. As artificial intelligence grows in complexity, we face the uncomfortable question of whether intelligence and consciousness are the same thing. Are we teaching machines to think or merely to imitate thought? And if awareness is an emergent property of complexity, what happens when a machine crosses that invisible line? The soul, that always elusive property, remains unsighted, but a possibility we cannot yet rule out. If so, if it or something like it exists, then perhaps consciousness is not a side effect of matter at all, but a property of the universe, waiting for complexity to summon it into focus, much as gravity rises from mass or magnetism from motion. For now, our existential uncertainty remains. We still stand far from the horizon of understanding both life and mind, two phenomena that might prove universal. The day we solve those riddles, we won't just have learned about the cosmos, we'll have learned what it means to be part of it. The spirit of discovery. As another year draws to a close and the nights grow long, it's worth remembering that wonder is one of humanity's oldest traditions. Long before telescopes or particle colliders, people looked up at the winter sky and felt the same mixture of awe and curiosity that still drives us today. Every unanswered question is an invitation, every mystery a doorway to something greater. Whether we're probing the first moments of the universe or tracing the faint chemical breath of life on a distant moon, each act of discovery adds one more note to the great song of existence. It is easy to see science as a pursuit of answers, but it's really the celebration of questions, an act of faith that the unknown can be understood, and that understanding will make us wiser, not smaller. In the months and years ahead, we'll keep building new tools, new minds, and new dreams to explore reality's hidden layers. Somewhere out there, or perhaps deep within, lies the next great revelation waiting to be found. So, as you watch the stars this winter, remember, we are the universe discovering itself, a species born from stardust yet reaching for the infinite. The cosmos still has countless wonders to show us. All we have to do is keep looking up. Merry Christmas, Happy Holidays, and here's to another year of discovery.